So let's welcome Jared Yates. Now, what he has written is from November '89 to April 1990 in Belgium. There were over 2,600 reports of large black triangular UFOs. Then in 1997, Ed Fouche blew the whistle on the TR-3B. This craft was claimed to possess technology that allowed it to hover indefinitely. In March 2022, Sal Pais gave his first public appearance where he details the Navy patents, which include plans for a TR-3B-like airframe. So in this presentation, Jared is going to propose a few avenues that might help us realize this technology. So everyone, let's welcome Jared to the call. And Jared, if you would like to get started, sir, thank you very much for attending and presenting.
There we go. Hey, everybody. I have a lot on this show. The first half is going to be mostly just introducing a bunch of concepts, and then I'll get to the good stuff with the TR-3B stuff more towards the middle. So, different ways that we can realize TR-3B and or warp drives. First, a little background about me. I spent 11 years in the Air Force, the Air National Guard. I was doing F-15 integrated electronics, avionics, the same job that Ed Fouche had for a while prior to going to Area 51. From the Air Force, I got an associate's degree in integrated electronic systems from the Air Force. While in the Air Force, I was studying electrical engineering. When I left the Air Force to go pursue physics, I did a couple of years of physics. And then since leaving college and going back into the commercial sector, I've continued some education with electrical engineering. Currently, in the commercial sector, I work in aerospace as a mechanical electrical engineering technician. Also, just as an aside about me, I am very heavily involved with Charles Crawford and Todd Desiato and Jeremiah with the Gravitational project. That takes a fair amount of my time. For many years, my motto has been that I'm going to see a warp drive before I die. I know it's going to happen. You just got to keep the faith. It's coming one of these days. So that we can have a shared mental model of what I'm talking about with the TR-3B, for anybody who hasn't seen it, I have shamelessly taken this image from Jeremy Reese's Alien Scientist site, who, by the way, definitely lit the fuse 12 or 13 years ago when he released his video on YouTube about all this stuff. It floored me. It's amazing. Jeremy, big shout out to you. So you can see some of the dimensions here in the upper right. It's about 60 meters by 10 meters-ish, tall and wide. Not all of these images, though, are of the TR-3B. There are some that are of the TR-3A, which use completely different mechanisms, as you can see in the lower right-hand side. Whoops. Also, I think there's some disinformation campaigns out there. There's been some CGI videos released of what people are claiming to be the TR-3B. I don't think that's the case. In the upper left hand, you can see that CGI model. There's a couple other videos of it supposedly flying through Afghanistan and other videos of it shooting laser beams or gamma ray beams or something and blowing stuff up. I suspect that's all a disinformation campaign. Also, in the lower left-hand side, you can see another image of that TR-3A. That image was actually taken right over my base here at Portland, Oregon, back in 2019. I reached out to some of my buddies that are still working there to say, hey, did you guys see this sitting on the tarmac? Because it would have sat just a couple hundred feet away from where we worked. Unfortunately, I don't got enough contacts there anymore and nobody remembers it. It was too many years ago. Also, it would have been a night flight and most of my friends were on day shift. I think that picture was taken sometime around 6 p.m. or so. Also, on the right-hand side here, you can see this is a Google Earth image taken from 2004. I just screenshotted this image on Google Earth a few weeks ago. It's still there. It was measured at about 100 meters on a length on one side, which does not line up with any of our current understandings of the size of this. Its size should either be 200 feet or 600 feet on a side. And this image doesn't quite match that. So maybe it was at a different height, or maybe once again we're dealing with disinformation, or who knows. Just what I'm trying to say is keep your skeptic hat on with everything with regards to what information you're presented, even including mine. All right, so I got a little compilation I put together here of 3 different instances of the TR-3B that I'm going to try to play now. This image was taken supposedly in 2009, I want to say, over Paris, France. And I got a slowed down version of these light ball resonance modes. You can see that's the first resonant mode. Now in the second resonance mode, notice how the top is slightly different shape than the bottom. It's not a perfect sphere. And the third, we're still kind of wavering in the light ball. It doesn't stay steady and then just disappears and is gone. This next image, I'm dubious whether or not it's real or not. I think it still demonstrates the idea. The difference is that you don't see a charge up of different resonance modes. It's just a single mode and then it shoots off, which is part of what makes me dubious about it. Also, that looks maybe CGI. This image was taken from military.com, a civilian website. I find it useful for a few reasons. One, you can see that they can orient themselves in any direction, which means that it's Z, it's vertical. Thrust doesn't necessarily always have to be coming from the center of the ring in the middle there. One final thing to note about that is that at the third resonance image there that we see on this first video, when it just flashes and disappears, all of these resonances, we may be dealing with shutter artifacts from the camera that was used. There may have been a completely different thing than the human eye would have been seeing, or that a fast camera would have been seeing. Also, by the way, anywhere where you see on my slideshow something that says link, I have the last few slides will show all of the actual links to these so that you don't have to click on them, you can see it. So the lower left-hand image on this was supposedly taken during that Belgium wave from 89 to 90. In 2011, the guy who released the image came forward and said, no, it was all a fake. I faked this image. Once again, remain dubious about any actual images that you see of the supposed TR-3B. That upper right-hand image that looks quite similar was taken from bbc.com. I think it looks quite similar to that Belgium image, except you can see a lot more detail there. Some observations about it. When the TR-3B is getting ready to shoot off, it's not releasing light just from the lower side, but we see a fairly uniform ball of light coming from all around the craft. Also, the color of the light I find to be quite important. It's not, blue or red or green. It's white light, meaning we should be seeing a very wide spectrum of photons coming off this thing. The shape of it I also find to be useful, since the lower side in the second mode was slightly smaller and more hemispherical than the top mode, or the top side of that second mode looked a little more egg-shaped. That to me may present some useful information regarding how it is producing the lift. It's putting out more energy on the bottom than it is on the top. Also quite interesting is how the size and the shape of that light ball changes as it's going through its resonance modes. In the first one, we can see that the edge of the light does not extend past the craft, but then after that, it is. That may once again be an artifact of the camera. The camera is just getting washed out, but I tend to suspect that it's actually somehow containing a ball of light, which blows my mind. Also, and this one really just breaks my heart. A couple years ago, there was a YouTube channel called Redstone that had released a video of the TR-3B, in which in this lower right-hand image from the military.com video, that center white ball of light was in far higher definition. Unfortunately, the video has been taken down. It got taken down within a few months and I've never been able to find it again. But that center ball, it was cavitating in like 3 dimensions. It was squishing together on the sides, spread out, squished together on the top, spread out, squished together in the 3rd dimension. That may have also presented some very useful information as to why does it have a ball of plasma in the middle that is squishing in, uniform and different directions as it's just standing there hovering. The rate of the cavitation of that plasma ball, at the time I measured it to be somewhere between 1/2 second to 2 seconds. All right, so just a quick overview on what I'm going to be going through here. If you want to have a warp drive, if you want to warp space-time, you're not going to do it with a 9-volt. You've got to have some stupid, ridiculously high energy densities. They may be attainable through orbital angular momentum or spin angular momentum in optics, but I strongly suspect that they're using plasmas for many reasons. Phonons, or instead of photons, you have these packets of mass movement of particles rather than of electromagnetic particles. These may also be used for some negative effective mass effects. Then we can go into the Pais Effect and kind of break down a little bit more on what his talk from the 30th of March this year was talking about with the vacuum breakdown and how you can have some other lesser known effects from the Schwinger Effect. And then I will try to improve upon that by showing how we can more readily attain the Schwinger effects using superconductors. And then from that, I'll try to wrap it up with the Breit Wheeler process or the Dynamic Schwinger Effect, which may also help us understand a little bit more on what mechanisms the craft may be using to produce its flight mechanisms. Starting off with some useful acronyms and concepts. If you see anywhere SAM or OAM, I'm talking about spin or orbital angular momentum. I'm going to also describe what left-handed metamaterials are for those who don't already know. One of the most interesting and important concepts that I'm going to try to talk about is something called birefringence. And then surface acoustic waves are also quite useful for some of the negative effective mass from the phonons. So starting off with some spin or orbital angular momentum. If you have spin angular momentum, that's like a particle spinning on its center axis. Orbital angular momentum is a particle orbiting around a center axis rather than on that axis. So like a planet going around a sun versus a planet spinning on its pole. There we go. A little more about orbital angular momentum. This is how you can apply torque, angular torque, to light or particles. This allows you to achieve much higher energy densities in a more confined space. The plasmas that are described in the TR-3B may be asymmetrically compressed to be able to produce this kind of corkscrew shape you see in the center there. Left-handed metamaterials. These are going to sound kind of like birefringence, but they are slightly different. They can be very useful for focusing as well as just generating superluminal group or phase velocities. Especially important is that lower left-hand quadrant, quadrant 3, where you see what these left-hand metamaterials are. The little E stands for the permittivity, the ability of electrical charge to travel through space. And the U is mu, and that is the permeability or the ability of a magnetic wave to travel through space. Also, as an aside, in the upper right-hand image, you can see that's for backscattering. I find it extremely useful for all of these things, for all warp drive related things, to think of space-time as a optical lattice rather than to think of it in terms of fields. You have to use fields, but when dealing with reflected waves or transmission of waves, all of my research I find it extremely useful and helpful to think in terms of optics with regards to all of this. Birefringence. So when you have a normal medium for a light wave to pass through that is uniform, the polarization of that light is going to be unaffected as it goes through. If, however, there is an asymmetry to the lattice that the light wave is going through, one of the polarizations is going to be different than the other one, and so it will travel at a different rate than the other polarization. The one that gets the change is called the extraordinary ray. That is the oval shape inside the circle in the middle image. The unchanged ray is called the ordinary ray. On the lower right-hand side, you can see a block of naturally occurring calcite crystal. This has a natural birefringence to it, which is why you see the double image of the grid paper underneath, because one of the polarizations of light is traveling at a different speed, so you get two images. You can get birefringence just by, you get it in Scotch tape, you can get it in glass, you get it in many mediums. If you apply an asymmetric stress to that medium, then you're going to have an asymmetry in the lattice of that medium, which means you're going to have light waves traveling through that at different speeds. You can also get birefringence from something called the Kerr effect, which is like a stress inducement from electrostatic or electromagnetic fields on your medium. So when we're dealing with plasmas, you're going to have very strong Kerr effects because plasmas tend to have very strong electromagnetic fields. One more thing on birefringence, actually a couple more. So the normal birefringence that we saw in the calcite crystal is called positive birefringence. That's where the ordinary ray is traveling at its normal unchanged speed, and the extraordinary wave is the one that is retarded or slowed down because it's traveling orthogonal to the orientation of the cells of the lattice. Where it gets really interesting, though, is something called negative birefringence. And this is like a left-handed metamaterial. This is where your index of refraction for the changed direction is negative. You're having a negative index of refraction, which means you're also getting a negative permittivity on that axis. This is going to come in quite useful down the road in this show. One further thing on that. When you have a negative permittivity, that also means that you're probably going to be getting reflections of the passing ray. Also, I apologize, I forgot to put my disclaimer in at the beginning of this whole thing. As you can see with my educational background, I am punching way above my intellectual weight class on a lot of this. So keep a bowl of salt handy with all of these terms and topics I'm trying to describe, because this is what you get from Wikipedia and white papers. There is another further very interesting thing about birefringence, and that's called kinematic birefringence. So if your material is traveling at relativistic speeds, that will also change because of Lorentz contractions, the ability of that light wave to travel through that medium. And this is how you can achieve negative group velocities or phase velocities. Some very, very interesting things can occur from this. So the second harmonic, or the frequency doubling that you can get from birefringence, is where you're taking the extraordinary ray and you are lining up its phase with the same phase as the ordinary ray. This allows you to double the energy. The photons combine and are now a single photon of twice the energy. And this doesn't have to be done with just a single step. You could have this in a repeating pattern where it goes through one nonlinear crystal and a prism, and you line them up, and then you do it again, and then you do it again. And so you can keep on upscaling the harmonics of your light waves into very, very high energy densities. Just an aside, interesting fact that I came across in all of this, gravity waves can also demonstrate birefringence, and it has been measured. Negative birefringence of gravity waves has not yet been measured, but that may be a matter of time. Also, gravity waves are predicted to be able to tunnel, although I don't think we have observed that yet either. One other interesting aside, a group out of Tokyo, or I think it was Tokyo, they came up with a warp drive idea where you have two separate materials of different refractive indices, with one of those being a negative refraction. And when you pass an electromagnetic wave through it, there's no change in the phase, meaning that it is actually tunneling through the point where those two are touching, which would be a contraction of space, which, hey, we got warp drive. Mildly dubious, but very interesting nonetheless, worth at least a read. I'm not going to play this video, but for the following couple slides, this is very helpful. Whenever I'm talking about superluminal phase velocities or superluminal anything, we're not talking about faster than 186,000 meters per second or whatever. You're talking about how shadows can move faster than photons, right? If you take a laser pointer and you point it at one side of the moon and you sweep it over to the other side of the moon, the rate that you're able to sweep that is faster. The distance from the diameter of the moon is greater than the ability of the light to actually go from one side of the moon to the other if you were standing on the moon with a laser pointer. But what's actually happening is the spacing between those photons hitting the moon is just getting greater. Highly recommend watching that Vsauce video if you haven't seen it before. So in order to get superluminal E waves or extraordinary rays with negative birefringent material, they take, you can see the top wave, the omega-1 component there, and the omega-2 component below it. What you have is the ordinary ray is the omega-1 and the extraordinary ray is the omega-2. When these two are combined, you have a packet, and that packet can move just like I was saying, the photons going from one side of the moon to the other. That packet can go faster than the speed of either of those two components, and even faster than the speed of light, but you're not actually transmitting any information. You're not actually breaking causality and time laws when you're doing this, although it can be extremely useful for upscaling the energy of an electron at the forefront of that packet. So surface acoustic waves are kind of like the skin effect in electromagnetism, where the higher the frequency, the more closer to the surface the electro waves are going to travel. The difference being, though, that since we're dealing with matter and not electromagnetism, the depth of these is dampened a lot. You only get about 1 to 2 wavelength depth when you're dealing with phonons rather than photons. These present a really big problem with soliton research in fiber optics because you get these nonlinear electrostriction events occurring down your fiber optic, and that destroys the soliton that you're trying to get reflecting back and forth. Further about surface acoustic waves, they can have greater density than photons. Because they have more degrees of freedom, they have more possible polarizations. That means that you can get higher energy density from photon wiggling, or from phonon wiggling, than photon wiggling. This I would highly recommend reading while remaining dubious. There's been a few papers published suggesting that phonons, or sound waves, or surface acoustic waves, generate their own gravitational mass, that they actually carry their own amount of mass. It's extremely small. It's ridiculously small. 10 to the minus 24 is beyond anything that we're ever going to measure. However, there may be ways to upscale this into a usable amount, because like I said, you can have a very high density of phonon energy compared to photon energy. That paper from 2019 was reviewed by a guy from University of Oregon in my state. He took a more realistic view of it, and he was able to determine that they may be able to move matter from a more classical definition, but once again, we're dealing with extremely small amounts. Somewhat related, but not exactly the same. This is called the mega drive. This is where they use two masses with a nonlinear damping between the masses, and they are able to produce a net motion from the vibrating of this device. It has been tested and verified many times. Unfortunately, it seems like it has kind of gone quiet in the last few years, despite the fact that they have had what I consider to be a significant amount of thrust. 100 micronewtons for something that small is insane. I suspect, though, that the previous example from how phonons can generate their own gravitational mass is probably not responsible for this. This is probably more likely because of the nonlinear damping taking place. Similar to that nonlinear damping, so if you just go on Wikipedia and look up negative mass and plasmas, it suggests that plasmas can also create their own negative effective mass. However, the scientists that have tried to do this run into issues where you can only get negative mass, or you get negative indices of refraction. It's very difficult, near impossible, to attain both simultaneously. All right, starting to get into the good stuff. So the Strategic Defense Initiative, or SDI, came to bear under the under the Reagan administration, although the idea for it had started under the Nixon administration about 8 years earlier. LaRoche was one of the ones who was trying to get it going for a long time. It was responsible for a couple of things called Project Star Wars, or Project Excalibur, or Project Brilliant Pebbles. It was deemed a failure by the public, but that may not have actually been the case. They came up with thousands of useful patents for all things related to lasers, and there's been many medical advances from the stuff that came out of that. It turned into the Ballistic Missile Defense Organization in the mid-90s, and then that turned into just ballistic missile defense in 2002. So if you want to track where this technology has traveled and who is responsible for what, that's probably a good place to start, is just follow the changes in names. It may have led to a proof of concept for the Schwinger drive, according to Pais. he did not claim that. I'm saying that. If you try to see anything about SDI and you know, warp drives or anything, you're going to come up goose egg. It's not going to happen, because either it never actually was successful in producing that and it's all been a disinfo campaign, or it was successful, and go figure, all of these resources are very good at making sure that these technologies that they're trying to keep secret stay secret. I came across one interesting SDI report from the early 90s where they were talking about Project Black Star, which was a space plane that Lockheed was trying to develop. They said that it could cause background modification with very high energy releases. However, once again, remain dubious. That was speaking in reference to trying to identify nukes that were being launched. And so it may have been referring to cosmic microwave background modifications from high energy payloads rather than actual space-time background modification. So just another disclaimer for you. Can't talk about SDI without talking about LaRoche. He was an economist and he was working with the Russians in the early 80s, trying to convince them that SDI would be an alternative to the arms race that was well underway, and that it would be an economic boon to everybody involved. However, once it finally got underway in '83, the Russians broke off all ties, publicly anyways, with LaRoche. And one interesting point about the SDI was that Reagan's Secretary of State, George Shultz, spoke at Ed Teller's memorial in 2003, and he said the SDI was in part responsible for ending the Cold War, which doesn't surprise me. If you are Russia and you want to shoot off nukes, and you know that it doesn't matter how many dummy nukes you put out there with it, that all of them are going to get space lasered out of existence. I mean, that definitely puts a wet blanket on the ability for blowing everybody up. Some scientists that are very important to SDI. You can't talk about any Black projects from the 20th century without talking about Ed Teller. This guy worked at the Manhattan Project. He was pretty high up with Heisenberg. He's called the father of modern rocketry. He was the head guy at Los Alamos National Labs. Interesting aside, according to Lazar, when Lazar was working at Los Alamos, there was a colloquium with Ed Teller, and that was when Lazar walked up to Ed Teller, and Ed Teller just happened to be reading the newspaper with Lazar's rocket car or jet car, and that was the introduction that ended up eventually getting him his 9 visits to Area 51, if Lazar was telling the truth. One of the most interesting people I have come across in all of this research, though, is Julian Schwinger. This guy may have worked on SDI, but if he did, it was tertiary. They had a lot of overlap in the academic world, but it's with SAPs, it's kind of difficult to tell who's working on what. You have to just go off of their published papers and try to see where some of the overlaps in topics that they are publicly disclosing overlap with some of the patents that SDI was releasing. There was a conference for 24 of the brightest minds in the world at the time, a month before Roswell in June of '47. Rockefeller organization put it together. And Julian Schwinger was the spotlight in this because he was a Wunderkid. He got a Nobel Prize that he shared with Feynman and one other person for his work on quantum electrodynamics. The guy is one of the smartest people that we've had. Also, there was an international conference for lasers that took place that over many years, but Ed Teller and Schwinger were spotlight speakers in '87 and '88 respectively. And in those topics, they're all talking about, or in their talks, they're all talking about the role of lasers for directed energy weapons, and specifically how this can apply to the Strategic Defense Initiative's plans. One other extremely interesting person that I've come across with all of this is someone called Dr. Friedrich Winterberg. This guy was 16 at the end of World War II. He came over in 1959 through Project Paperclip. This guy's still alive today, crazy enough. He teaches out of University of Reno. Don't quote me on the name of the university, but it's the university in Reno that is responsible for like 1/3 or 1/4 of all their projects are super classified. Very interesting guy. Most of his stuff deals with plasma. He also strikes me as a mad scientist. This guy has had many crazy out there ideas, helpful contributing ideas on how we may be able to eventually have real space travel. But most of his stuff usually is dealing with blowing up nukes behind ships type stuff, or crazy antimatter reactors that may not actually be so crazy. I spoke a little bit about Project Excalibur there a few slides ago. That was where they were using nuclear pumped X-ray lasers, and then they would accelerate those lasers through a plasma. And this was supposed to be for shooting out nukes out of the sky, but it may have also been used for drilling and making some good underground excavation opportunities. So like I said, Winterberg is very big into everything plasma fusion related. A little aside about plasma fusion, you can't talk about it without talking about something called Alfven waves. These are whenever you wiggle a plasma particle, it's going to produce an electromagnetic field. So if you got really strong waves going through a plasma, you're going to get really strong electromagnetic fields. So I apologize, next couple slides, there's a lot of reading, but I find it to be quite helpful. So I will do so. You can get orbital angular momentum through plasma, like I was saying at the beginning of the show. If you do it through fiber optics, you get something called hole burning, where you're actually burning up your fiber optic the more you twist the light, and that is a problem. And just as another quick aside, I'm also very big into Charles Hall's recounts of the tic-tacs that he claimed to witness when working out near Area 51 back in the 60s. He claimed that over 2 years, he developed relationships with a race of beings called the Tall Whites, and that on one occasion, he actually got to see one of their craft with the panels off up close, as well as seeing many flatbed trucks coming in, bringing in thousands of miles of fiber optic cables. And that in his conversations with these beings, they told him that they were using fiber optic cables to be able to generate their flight mechanisms, which strikes me as quite interesting, because if we're talking about using fiber optics rather than plasmas, that means that they would be dealing with big temperature problems with their craft, which it also so happens Charles Hall described. They said that was a major problem, was that they had trouble controlling the temperature and keeping the temperature down on their craft in order to actually get from point A to point B fast enough to avoid bad people. Moving on. So if you don't want to burn up your material, you're going to have to use plasmas because they can handle much higher energy densities and temperatures and all that. Unfortunately, this gets very challenging because plasmas tend to be very chaotic. It's very difficult to get actual structures in them. But you can try to do so if you have asymmetric magnetic fields around the plasmas. which when you do that, you can end up getting optical vortices out of them. Moving on to superluminal plasmas. So you can get a massive energy boost of your electrons if they're moving at the wavefront of a plasma that is already in that superluminal group velocities described earlier. These are called plasma mirrors, which I suspect are one of the few major mechanisms that may be at play in the TR-3B. If they are able to generate extremely high charges and magnetic fields from the plasmas, this is how they're doing it, is by having a reflective plasma wavefront moving at relativistic speeds that is then reflecting oncoming laser beams off of it, so that you get really stupid high charges of photons and electrons at the reflection point. So if you suddenly photoionize a plasma, you're going to get a change in its refractive index. It's going to drop from 1 down to 0. You're not going to get any more refraction out of it. Semiconductors, it's a much bigger drop. The electron hole pairs that are instantaneously created when you hit it with a ton of energy cause its refractive index to change from 3.5 to 0. This ends up being something called a chirp. It sweeps up all the low frequencies into a ramping higher frequency modes. In soliton research, once again, in fiber optics, this is the majority of what I have found in anything referenced to being able to generate warp drives with fiber optics. Also happens a lot with lightning bolts. They tend to create these chirps where they ramp up all these lower frequencies by potentially thousands of octaves, getting very, very fast pulses. Once again, highly recommend looking into Vinterberg's research regarding this, as he thinks that sonoluminescence may be responsible for some of these chirps that are actually extracting 0-point energy out of the vacuum whenever you have this sudden photoionization of a material. Here's a useful image when I'm talking about these plasma mirrors. You get a deformation of a flat plane of plasma from a laser beam, a low energy laser beam hitting it from the back. And then when the oncoming laser beam hits the center of that, it's timed such that the snap of this plasma will accelerate the oncoming beam. Moving on to the Pais Effect, he, in his March 30th talk, did not delve super deep into a lot of things. He kept saying he had all this secret sauce that he wasn't going to be talking about. I strongly suspect that's because if they were using nuclear pumped lasers or nuclear energy sources, that would be breaking all kinds of international aerospace laws, which, you know, that's kind of a problem if the US is going to get in trouble with the world. Not to mention the potential for weaponization and all sorts of other things that can happen whenever you have nukes in planes that are used for their energy source. His gist on the Schwinger effect is that when you get a high enough energy density to attain the Schwinger effect, that it actually is changing the space-time metric enough that you're getting negative energy densities, or you are able to change the gravitational constant in these tiny, tiny little pockets such that it allows you to produce warp fields. I'm still mildly dubious about his descriptions, and I'll believe a lot more when he tells a lot more. So I've been talking about the Schwinger effect, the Schwinger limit a lot here. I'll actually go in and describe a little bit more on what it is. The Schwinger limit is what happens, like I said at the beginning of this talk, if you think about space-time as an optical medium rather than just a nothing vacuum, it can be quite beneficial. So if space-time is a medium, an optical medium that you're punching a huge amount of energy through, like I was saying, the Kerr effect, you get this electrostriction of the space-time vacuum that can occur strongly enough that you're actually deforming space-time enough, you're putting enough energy into it that it's changing the birefringent value of the vacuum. This requires extremely high energy densities, though, that have not yet been attained. Although we are getting very, very close in the academic world, we're still just not quite there. There have been analogs of it, though, that have been detected. We tend to see this effect out in space around things called magnetars, which are neutron stars that are producing the strongest magnetic field known to man. They also tend to be, well, I'll just keep moving on. So when you get all of this energy pumped into a very, very tiny space, all of a sudden these particle-antiparticle electron-positron pairs just spontaneously start coming out of the vacuum. You have altered the value of the vacuum enough that the tunneling energy required for quasi-particles, virtual particles, things that don't physically interact as far as we understand, generally speaking, they're able to tunnel through that energy difference, and now they're actually popping into an existence. An analogy that I could provide for this is, imagine you're standing on a trampoline over a swimming pool, right? And normally just your weight on standing on that trampoline isn't enough to deform the trampoline enough to actually get the water from the pool to come up from underneath it. But if you get a bunch of people standing right in the middle, maybe you can bend that trampoline enough that you start getting water coming up through the grating of the trampoline. That's kind of what's happening with this. You have something called the Dirac sea, which is all the electrons, anti-electrons, it's all the charge aspect of the universe that's existing all around us in numbers that are way too high to even make sense, but they don't actually interact with us because they are in a virtual state. If you change the value of the vacuum enough, they go from being in a virtual state to being in a physical state. And this is amazing to me that you can produce antimatter from the vacuum if you have enough energy. Just blows my mind. Schwinger is a friggin' genius. So if you go beyond the Schwinger limit, so the Schwinger limit is 10 to the 18 volts per square centimeter, which is a lot. You get something called higher harmonic generation. And this is where it's that sweeping up of those lower frequency waves into higher frequency waves. Because like I said, we're changing the birefringent value of the vacuum. We're changing its ability to transmit frequencies through it. So going back to the plasma mirror effect that I was talking about a few slides ago, you can see that these plasma mirrors are able to upscale these lower incident lasers into extremely fast lasers. We're talking attoseconds. It's beyond ridiculously fast. In, was it 95 or 96, SLAC, the linear collider, they managed to create about 100 pairs of Schwinger particles using this. However, that was inelastic scattering, not elastic scattering. So in order to be the true Schwinger effect, it would have to be elastic. I just think it's amazing that almost 20 years or 25 years ago, they were actually managing to do any energy densities enough to produce particle-antiparticle pairs. That's further in support that perhaps SDI had managed to master this even a few years before them, as secret programs tend to be a few years or decades even ahead of the commercial and academic sectors. Here are some numbers that I got from Ricardo Storti, if he's on. Big thanks for this. I'm trying to describe in this flow tree the different methods that you might be generating enough energy densities to be able to produce warp fields. However, unfortunately, neither one quite gets there. If you wanted to use solely orbital or spin angular momentums from a nuclear pumped laser exciting a plasma, it's not going to quite get there. It's going to be at least half of the way. If you want to use plasma oscillations for that negative effect of mass I was saying before, where the phonons are producing 10 to the minus 24 of the gravitational constant, once again, you're still not quite getting there. If you want to actually alter the vacuum enough, you're going to have some crazy asymmetric electrical or magnetic fields that are generating their own thrust, which sounds like crazy sauce to me. Schwinger effect is probably far more likely than using just regular energy densities you'd get from OAM or plasma oscillations. For the power supplies for the TR-3Bs, small modular nuclear reactors, maybe some of you have heard of these before. These are nuclear reactors that are orders of magnitude smaller than the normal ones that we see and use today. They tend to produce less energy than those multi-gigawatt facilities. These things can produce up into the hundreds of megawatts though. SDI was in part responsible for the research that came into play to be able to make these. Back in the early 80s, they were producing these. If you wanted to have enough energy, half a gigawatt, to even begin to alter the vacuum, this is one of two ways that I have found that they would be able to do it. Is they're gonna have 3 of these, one along each leg of the triangle, or they will curve them and make a ring. I'm a little dubious about curving these things because nuclear reactors are hard and you put curves in them and now they get even harder. So probably not likely. A helpful diagram there at the bottom shows the official record for the laser power outputs that humanity has been able to achieve. You can see by about 1990, officially we were over the terawatt range. In order to achieve any of these energy densities necessary, we would have had to be much higher, probably closer to the petawatt range, which you can see we didn't even really start hitting until around 2000. But like I said, all the resources in the world and all the geniuses in the world at the military's disposal, who knows, maybe they managed to be a couple decades ahead of the curve on this as well. SDI worked on something called Project Sprint. And this is where they were using fuel cells connected to these modular reactors in order to try to get gigawatt production. They never actually disclosed their success of Project Sprint. It's hard to say whether or not that's because it was a big failure or because it was a big success. Like many things with these SAPs, it's real hard to track. One of the most interesting things I have found for the power supply of the SDI programs are things called superconducting magnetic energy storage. This is where you use a superconducting material and you put a bunch of magnetic energy into it, and it can store that magnetic energy until you hit it with a laser, you do something to destroy the superconducting effect, and then boom, it shoots out all of that magnetic energy in an extremely short time frame. As far as I understand the commercial sector, we've only gotten up to like 1/4 of a gigawatt to 1/2 a gigawatt using these. But an SDI paper from 1989 suggests that they were looking into this for multi-gigawatt energy storage. They would have been using this using magneto-hydrodynamic reactors. another aside, for any of the links that are paywalled, I would never be one to recommend using something to get around paywalls like Sci-Hub or any of those sites, because Sci-Hub tends to be far too useful in these efforts at researching. So definitely, whatever you do, don't use Sci-Hub to get around paywalls. Anyways, let's go on to the next one. The plasma, mercury-based plasma that Fouche describes, he claims that it's ridiculously high pressure. It's at 250,000 atmospheres of pressure, or 25 gigapascals, and that it's super cooled down to minus almost 200 degrees Fahrenheit, 150 Kelvin, and that it's moving extremely fast. If you look at the, I think it was the 200-foot model, the 50,000 or 60,000 RPMs that he describes means that it's moving somewhere around 500 to 700 kilometers per hour. I got an image there in the upper right from one of the papers that I've got on this. Mercury has been tested at these conditions, not just mercury, it's a mercury-based cuprate or superconductive material. The fact that this has actually been tested blew me away. I can't believe it. And the red lines that you see in that image are using Fouche's numbers of pressure and temperature. And you can see that we actually have 3 different forms of mercury cuprates that were tested in that. And one of those falls extremely close to the numbers described by Fouche. Extremely interesting to overlap there. However, these pressures are extremely difficult to get. The experiment that I'm just describing there, they were using diamond anvils. And I don't think the TR-3B is using diamond anvils. It's probably just using really strong magnetic fields and or compression of the plasmas to get these kinds of pressures. But yeah. One description of a similar type of warp drive using these spinning mercury-based masses, something called Ford's rotational field. He worked for Hughes Laboratories, and he suggested that you could actually create dipole gravitational fields. I'm dubious about. We haven't ever seen anything even close to indicative that gravitational fields can produce a dipole moment, maybe a quadrupolar moment, but not a dipole moment. And he said that you could accelerate liquid mercury around a toroid, similar to that tokamak image that I got there on the right. And especially that if it's superconducting with a very strong electrical current, that you'll get very high electromagnetic forces as this toroidal field starts to envelop it. Mildly dubious about that. Maybe there's a there. I don't know. I just don't know on that. Now we're getting into the real good stuff. So the Schwinger effect was 10 to the 18 volts, right? How on earth are we ever going to be able to achieve that? Sal Pais was suggesting that there was a secret sauce there, that there's a way that you can actually make this attainable. The superconducting Sauter Schwinger effect may be the way that this is done. If you have a superconductor, it has a bunch of Cooper pairs in it, and the band gap, the difference, the distance of that trampoline above the water is much, much lower. So you're getting double the number of quasi-particles. You're getting much easier ability to achieve those quasi-particles into real particles when you're using a superconductor. Ridiculously easier. We are able to go from 10 to the 18 volts per centimeter down to 10 to the 8th volts per centimeter, or 100 million volts. And 100 million volts was very readily attainable for many, many of the past decades. That is not outside the realm of possibility like 10 to the 18th volts are. And this has actually been somewhat demonstrated in graphene. And they were using terahertz lasers in the graphene to be able to achieve this. Also, regarding how Fouche was saying that the mercury-based plasma was spinning at tens of thousands of RPMs, that one has always kind of stuck in my craw as to why on earth do you need to spin this stuff? Shouldn't you be able to do it in a solid state? one of two reasons to do this would either be because you are decreasing the band gap further by getting it under even more pressure, or that was one of the ways that they were being able to achieve those super high pressures was through the centrifugal force of that plasma. Another reason would be that is how they are achieving extremely strong magnetic fields. Oh, and just as a side note about this, officially terahertz lasers weren't created until 1995, but Ed Fouche is claiming that the TR-3B was in existence since at least the early 80s. So once again, the potential that the leap of faith that the advancement in technology that was not disclosed must have been in existence. You got to take that leap in order to believe that the TR-3B was as Ed Fouche described. Here's an interesting convergence between effects that I wanted to note. If you have a superconductor and you're hitting it with really high voltages, that sounds a lot like what Eugene Podkletnov was doing. He took a really big superconductor and spun it really fast and then hit it with many millions of volts, similar to what we're describing may have been occurring in the TR-3B. He suggested that there was up to a 2% weight loss. He was only getting 10 to the 6th volts though, and we're saying you need 10 to the 8th volts in order to actually achieve this. You still are achieving it, but at 10 to the 8th volts, it's 100% pair production. Anything below that, and it exponentially decreases in the number of pairs that you're going to produce, which may be why Podkletnov was only getting, a couple percent weight loss. Still don't quite understand how you can get weight loss from particle pair production. I wish I had an answer for you on that, but jury's still out on that one. But just the fact that there may be overlap between Podkletnov's claims and Fouche's claims, because we are using superconductors with very high voltages that may be producing the Schwinger effect or the Pais effect. Another topic that you should probably be somewhat familiar with is called the Unruh effect. This is like the Doppler effect. If you are flying through space and you're accelerating through space, you're going to see all of the EM waves ahead of you compressed or blue shifted. You'll see all of the EM waves behind you stretched or red shifted. What this means, though, is that these relativistic plasma mirrors that I was talking about, they're going to be producing very high Unruh temperatures. And you can see here, this was one of the papers I came across. They were saying that if you use a stupid powerful laser colliding with an electron, it's going to produce 1,000 Kelvin of Unruh temperature as noted by that electron, which if we have a superconductor, this is a problem. Moving on, here is an antimatter drive that was worked on by NASA for a while, or an arm of NASA. It's called Project Icarus. It was a spinoff off of Project Daedalus, which took place from 74 to 78. Icarus was from 09 to 2019. This was just research-based. They didn't actually do experiments with this. They only utilized the experiments that had already been done and took the data from that. But they came up with a model for an interstellar craft that was using the Schwinger mechanism to create these antimatter particles that you need to be able to get the amount of energy that you need. If there's aliens out there, or if there's other intelligences out there, antimatter makes the most sense because bang for your buck, you get the highest conversion of matter to energy when you have antimatter annihilation. According to Project Icarus, though, they were suggesting that you're only going to get somewhere around 1,000 positrons or 1,000 particle pairs per MeV, which is nowhere near enough to be able to actually see any of the effects. You're going to need many orders of magnitude more particle production per energy input than what these very smart people from NASA determined. Coming back to Friedrich Winterberg, he talks about this saying that you can have an antimatter plasma or matter antimatter plasma. He calls it an ambiplasma, and that when it collapses, he's big into Z-pinch type fusion things, so makes sense where he's coming from. If you have an ambiplasma pinch, that you're going to get much higher rates of production of the antimatter. I wish that Dr. Winterberg would have worked with these NASA folks, because I'm sure they could have come up with even better models for a antimatter spaceship. So when you have antimatter particles colliding, they tend to give off gamma rays. This can be described by the Breit Wheeler process. Although in the Breit Wheeler process, you have multiple gamma ray photons that collide in the regular Breit Wheeler process, and they end up creating matter from light. In the nonlinear Breit Wheeler process, though, which is the lower right image there, you have a single gamma ray photon that is just in a very strong electromagnetic laser field, like the Schwinger Effect. And that is how you're getting the antimatter production. In fact, there is strong overlap between the nonlinear Breit Wheeler effect and the dynamic Schwinger effect. So speaking of these gamma rays, though, that are going to be produced from this, I started looking through the literature and the accounts to see, well, have UFOs ever produced gamma rays? And it turns out they have. A documentary that just came out like a week or two ago from a team called UAPX. They ended up getting a lot of really good data. They set up a bunch of cameras and sensors on top of a rooftop down by Catalina Island, California. They had multiple locations so they could try to triangulate any of the UFOs that they spotted. In one of the encounters, they had triple repeating gamma ray emissions that were far above the background gamma ray emissions. Background tend to be about 2 MeV. Their average was around 10 MeV gamma rays. And the fact that they were triple repeating was extremely interesting. More interesting was the fact that they had their largest spike, which was 43 MeV, from a thing that was a couple miles away. So it stupid high energy densities that are coming from gamma ray emissions. And as far as we understand, in order to get gamma rays, you got to have either antimatter annihilation, or you got to have lasers that are far beyond what can really be produced right now. Getting close to the end here, we got a Feynman diagram for anyone who hasn't seen one before. I got the following slide. You're gonna have to be able to read it. So you can see the arrow indicates time as we're moving through time. Orthogonal to the arrow would be the space dimension. So you can see on the left-hand side, we have an electron and a gamma ray that are coming together. And then when they collide, that electron now is going to have a lot more energy such that it can't hold on to that energy, and eventually it's going to emit another gamma ray, and that's going to deflect it. That particular example that you see before you is Compton scattering, which was briefly described by the previous speaker. So here I've been mentioning the Breit Wheeler process. If you look in the lower right-hand side, you can see the Feynman diagram for that, although it is rotated. Starting from the top and moving down to the bottom is our time direction. So you can see we have a gamma ray coming in with an electron. They come together, and then the electron spits off and it produces another gamma ray. Although what's not shown in this is that it's actually producing positrons, and that it is the mirror image of Dirac annihilation, which is quite useful in much of this research. All right, so bringing it all together. If you take a petawatt level, super fast femtosecond laser and you shoot it through a special film to produce plasmas, you can then focus that plasma, give it a curvature to produce a plasma mirror, which can reflect another laser beam being bounced off it and upscale that laser beam even further. So we can get very, very high energy densities, maybe even to the level to attain the Schwinger effect. And the fact that these are altering the refractive index of the vacuum blows my mind that this was even figured out, and especially figured out 70 plus years ago. Especially because once you're changing the birefringent value of the vacuum, certain nonlinearities start taking over. The vacuum changes in extremely useful ways. Instead of being a linear change in the amount of particles produced or effects noticed, you start getting an exponential increase. An avalanche of this starts occurring above the Schwinger limit. Further, if you want to attain it, you're going to probably have to be using superconductors, which is very useful because that's what falls in line with everything else that we've heard thus far from Fouche or other sources. Alternatively, the nonlinear Breit Wheeler or the dynamic Schwinger effect may be actually damping EM waves because of the ambi plasma described by Winterberg. This damping of EM waves may also fall in line with some accounts of UFO or UAP data collection, hard to determine. One of the most interesting things about this, though, is that the Breit Wheeler process may not have normally rated decaying magnetic fields. It may have a much slower decaying magnetic field. And I cannot recommend watching this video link that I have here enough. This is a young guy who's working over at Brookhaven, who gave a talk down in Brazil. And he determined that we can get up to 10,000 times stronger magnetic fields from the Breit Wheeler process than are even noticed by magnetars, which are already the strongest magnetic sources known in the universe. Also, these extremely strong magnetic fields has a touch of overlap in tone with the magnetic field disruptor technology described by Fouche of the TR-3B. So trying to identify, why it's all secret, aside from the fact that it's, next level tech. If they were using nuclear pumped lasers, nukes are illegal in space or in the air. Also, if they were using small modular nuclear reactors, those also are illegal, especially if these things are still flying to this day. Really hard for Uncle Sam to come out and say, oh yeah, by the way, we got this cool tech that we may have been flying over everybody's houses, producing gamma rays and causing potential for massive nuclear fallout should any of these crash. It makes sense why they would have to keep this secret, not just from a technological standpoint, but also from a public safety standpoint and from an international diplomatic relations standpoint. Also, because of the flight capabilities claimed of this craft, if they're able to deter nukes that are being shot off, this is something that you would want to relay to your enemies, but you wouldn't want to relay in such a way that they can figure out exactly what your tech is. You want to talk about the capabilities, but you don't want to talk about the way that you're getting these capabilities. So you have to reduce the amount of info that you give and only give enough info so that they know you can, not how you can. Also, these may have been developed in response to UAPs that would have been hounding us for, since time immemorial. Hey, finally, we got a way we can actually chase these things. That would also make sense why it would have to remain a secret, because it's part of the program, right? It's part of the UFO secrecy world. So if you come out with this thing and you say, oh, by the way, we've been chasing UFOs with this, once again, big can of worms. Just so many aspects of this require secrecy that makes sense. Not to mention that if they're producing these extremely high gamma rays, that is a potential for weaponization that you most certainly do not want any enemies to be able to identify. There's still a lot of questions, though. in the official commercial academic world, we're still not there even today, 30, 40 years after the fact, for the amounts of energy densities and laser energies and speeds of the lasers, all of the metrics required to attain this. We aren't there yet. And you're supposed to believe that 40 years ago, a group with unlimited resources and brains managed to be able to attain this. It's a slight leap in, more than a slight leap in faith. Alternatively, there may yet be different methods for curved relativistic mirrors, those plasma mirrors. There might be different methods that they're using to produce these that we don't know about. There might be a completely different grand unified theory that they're working with to be able to produce these things. I might be way off in left field because it turns out they have a totally different model of the universe, which allows attaining these Schwinger limits to be even more attainable. As just one bit of evidence, though, to try to help the faith that maybe this has been possible, that they've possessed technologies for 40+ years that we still can't even begin to imagine today. DARPA is regularly 20 years plus ahead of the curve on all technologies. By the time you find out about technology that has been produced from any government contract, generally speaking, rule of thumb, it has been researched and produced for a minimum of 20 years. So suggesting that the most secretive project in all of the Black projects was at least 40 years ahead of development, maybe not so unbelievable. Just as a further aside to that, Ed Fouche talked about when he was working at Area 51, he was working on their satellite tech and their satellite receivers, and he claimed that in 1979, he saw FPGA processors, which weren't a thing yet. He saw these things the size of a Zippo lighter on the satellites, and that these processors were operating at about 1 gigahertz in 1979, when the fastest normal processor out there was, barely even getting into the megahertz range. So it's possible. It's possible that there's faster tech, better tech out there that we just haven't got to yet. Wrapping it all up, maybe the TR-3B is using plasma mirrors, or maybe it's using negative effective mass from plasma oscillations. Just a lot of conjecture remains. So I have a Google Doc here with a link down at the end. There's a lot more that I haven't even begun to touch on potential avenues that it could be utilizing. I tried to condense it into just a few here, and even this was not very condensed. And now I'll just leave each of these links slides up for a few seconds so that anybody watching this as a recording that doesn't have access to these links can just type them in. The green ones are the ones that I highly recommend people go take a look at. That's what I got.
Man, Jared, that was wonderful. In fact, there are people in chat texting me going, "This is amazing. This is so much more than we thought he would present." So thank you so much. So in terms of this document, you have a ton of resources. If you're able, I mean, you can just email it to me if you want. I will put a link up to this in the replay, right? And that way everybody can see this. Since it's a Google Doc, just make sure to share a read-only link, right? And that way, nothing happens to it. Nobody accidentally changes anything. But yeah, if you have a link to share, I'm happy to put this up in the meeting notes. You can also share that link in chat also. But before I do anything else, though, what I want to do is I want to stop your screen sharing, and we need to give you an applause. Everyone, tremendous applause for Mr. Jared Yates. Jared, Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. That was, yeah, incredibly detailed. And I love the fact that you did synthesis on so many different sources and you cross-referenced so many different things as well. That really makes it amazing.
I've just posted in the chat to the link to the Google Doc for anybody that wants it.
Oh, wonderful, wonderful. Okay, and you know what I am going to do here is I will pop that open, and
also the very last link on that links slide is also the link to the Google Doc. So anybody that is watching this as a recording, that you can type in that stupid long address and get to it there if it's not already in the description of the video.
Perfect. I got that as well. And let me see it. Yeah, no, it looks like it's not editable, which is good. We don't want to. Yeah. Okay. Perfect. Okay. Well, so again, thank you very much.